Hi everybody, welcome to Mueller Planetarium Astronomy at Home. This is Zach Thompson, Planetarium Coordinator at the University of Nebraska State Museum at Morrill Hall here in Lincoln, Nebraska, wishing you all the very best. Today we're going to go planet hunting using a wonderful software called Stellarium. As you see to the right on your screen, our friendly sun holding up the website stellarium.org or stellarium.org. That's where you can go to download this. It's available on many platforms, and I think you'll find one that's the best fit for you. When you have this fully installed and ready to go, I'll make this go full screen for us to give us a similar view. First, come down here so you can set things up. It might prompt you to ask about your location. We have it set for Lincoln, Nebraska, and your location does matter. The sky will be different depending on where you are anywhere here on the Earth. So it's good to give you an idea of where you are to set the sky up for where you currently are located. Just so again, so you know what's going on in the skies above you. It could be now, it could be in the past or the future, but this is a good starting point for all of us. If you come over here, you'll find the time console where you can go forward and backward in time. Here we are facing to the west, and you'll notice that there's the sun and the moon following shortly behind it. A very sliver of the moon, in fact. The things in our sky here on Earth rise in the east and set in the west, and that's just the rotation of the Earth. That's its spin, its daily spin. Here in the early evening skies, you'll notice this bright white dot before it's very dark out. In fact, if you're looking for stars, you might have already been seeing this and counted this, but this is no star at all. In fact, this is a planet, the planet Venus. Here's our time, just about 8 o'clock. And if you come over here, whenever you click on any object in Stellarium, you'll find maybe a box or a circle, or in this case some red lines, but then to the left you'll find a menu saying you found Venus, it's a planet, and a variety of other things for you to explore on your own. But Venus, as you see here, is roughly how it'll appear to you in the night sky. It might be a little bit more exaggerated just to draw your attention, but otherwise Venus is the brightest thing in the evening sky unless the moon is out and unless the moon happens to be a bit fuller as well. Otherwise, this takes the cake. And people long before us noticed Venus. It's hard to miss this beacon in the sky. The Greco-Roman civilizations attributed this as being the goddess of love and beauty, so they gave the name Venus or Aphrodite. Bring up the label here just in case we forget. And she was named after the Roman goddess of love. This planet was here, but in reality, Venus is a bit different than that. To the ancient people, they called planets planets because it meant wanderer, which ultimately just means that they move differently against the backdrop of the sky. Compared to the stars, they move differently. But they didn't know that they were other worlds. Today we know that Venus is in fact the hottest planet in the solar system, and that's because it has a very thick atmosphere of clouds. These clouds trap the heat from the sun in something called a runaway greenhouse effect. So every day on Venus is almost 900 degrees Fahrenheit, if you can imagine that. It also rains sulfuric acid, and there's a lot of pressure from that same atmosphere. So even though this is named after a lovely god, a lovely goddess or character from mythology, it is in fact the opposite. It's quite different from our own beautiful world here on Earth. Sometimes it's been said that Venus is the sister planet to Earth, but that's only because they are about the same size. Otherwise, they are totally different. Think of Earth as the good twin and Venus as the evil twin. So we really can't live on Venus. We don't expect that there's any life that we know living on Venus because of the harsh environment. And we've not been able to send a whole lot of spacecraft to land on the surface of the planet. I'm going to zoom us in here, and you can do the same thing if you have a mouse at home, that scroll wheel. I just used a keyboard shortcut just to keep the motion of the mouse here to a minimum, just so we're not getting too overwhelmed by what we're seeing here. But as we get closer here, notice how you see the clouds right here all along Venus. This obscures your viewing of the surface. So we wanted to know what the surface of Venus looked like decades ago, and we were able to put some landers there, but they only lasted a little more than an hour or so because of the harsh environment. So in the meantime, we have spacecraft in orbit around Venus, monitoring the weather, changes in, for example, the surface. Is it active volcanically or geologically? Things like that. But NASA and other space agencies around the world do have hopes for returning to Venus with maybe stronger, more durable machinery or spacecraft in the future. Because all the planets are different. Like people, they're special in their own way, and so we'd like to know more about all the planets, including Venus, to better understand the whole solar system. Now notice here how Venus is in a phase, kind of like a half Venus, sort of like our moon. Venus does in fact go through phases. It doesn't go as quickly as the moon phases do, but you can see them if you have at least a small telescope, sometimes a really, really good pair of binoculars. But something else that's interesting about Venus is if you have the right conditions where it's so dark, the brightness of the planet can sometimes cast shadows. Again, you have to be in the right dark conditions. Plain and simple, the darker the better. So don't be in a place that's around city lights, car lights, street lights, even the light from your phone. If you're out in the country sky setting, that's much better. But sometimes try that for yourself. If you see Venus and you're in a dark enough area, see if you can see a shadow at all that's attributed to this bright beacon in the sky. Now, one of the reasons why it is so bright, as I back us away here, is because it is the closest planet to the Earth. And those same clouds that trap the heat from the sun also reflect a lot of sunlight, kind of like a mirror does. So here it is to just the naked eye, but if you have a small telescope or binoculars, it's a little bit bigger and a little bit brighter. So now we click away from Venus. If you have a mouse, the way to click off of that is to click the right mouse button. And then we're going to move our sky over here to the east. We're actually southeast. We're going to go over here to the southeast. This is a good place for us to be. We're going to move time forward, and you can watch the progression of time here, or you can just watch it in the sky itself. Remember, things rise in the east, set in the west. You will occasionally see star labels come up, which are classic springtime stars, and we are going to talk about them in some future videos. But for right now, we're interested in the planets, because there's not one, not two, but 4 planets that you can enjoy at this time of year, particularly in this month for March, even leading into April. So here we are again to the southeast, and we're coming here in the pre-dawn skies. And look at these 3 bright objects. These are our 3 planets. They are Jupiter, Mars, and Saturn. Jupiter is the brightest of the 3. This is the biggest planet in the solar system, so large in fact that more than 1,000 Earths could fit inside of it, and you'd still have some elbow room, so it is quite large. It's about 500 million miles away from the Earth, and the reason it is so bright is because it's so big and it's covered with clouds, like Venus is. Those clouds reflect a lot of sunlight. If Jupiter were in the sky at the same time as Venus, you would see Venus being brighter because it is closer. Otherwise, it's understandable why some would mistake Jupiter as Venus. So see for yourself how bright it is in the pre-dawn skies. Next to Jupiter in our sky is Mars, brilliant red Mars. We'll hide the labels just so you can see it a little bit more easily there. Mars is about that red to just your eyes. The darker the skies that you have, the more red it appears. If you have binoculars or a small telescope, you'll notice that it's even more red. The red color is because it's a rusty planet. I think we've all seen iron, and it looks like rust. It has that red-orange color. If you've seen someone left their grill outside and they had the cover off and it rained for a long period of time and eventually it started to rust. So we know what that color looks like. Well, there's iron on Mars, all over the place on Mars, in the atmosphere and the dust and the soil, and it has rusted. That's what we're seeing. That's why it's so red. If you would like to see Mars look even more red, though, what you can do is take an empty roll of toilet paper or any tube that you can hold up to your eye, close your other eye, and aim it at Mars, because what that will do is block out the rest of this stuff. So your eye is focusing here just on Mars, letting in as much color and light as possible. I think you'll be really impressed at what you can see, so I encourage you to do that and write down your observations. Just look at Mars with just your eyes, and then try it with that tube, or binoculars, or a telescope. And how are they different? How are they the same? When you make observations like that, you're doing what astronomers and researchers have done long before us, what they do right now, and what they will continue to do. Observations matter. It helps us track how things change over time, and that's a fundamental basis of any science. And then just over here is Saturn. Wonderful Saturn, the ring world. Now, it's not going to be quite as bright as these other two, because it's about 800 million miles or so away from us. However, all 3 of them will be a little bit brighter than the stars nearby in the sky, and it's hard to miss because the 3 are so close to each other. I also want to show you Mars, because watch what happens when we go forward in time, one day at a time. So here we are Here's our current time that we have situated. If we go forward a couple days at a time, look how Mars gets steadily closer to Saturn. That means it's even easier to spy. If you've got binoculars or a telescope, you can see them in the same field of view. It really is spectacular. And again, write down your observations. What do you see? As time goes forward, as we head into April, Mars keeps moving. This just shows you how everything in the solar system is moving. Nothing stays still, and this is a fantastic way to watch it all with Mars as your marker. Planets that are closer to the sun, like Mars, move faster around it, whereas planets that are farther away from the sun, like the gas giants, they move more slowly. So when you have the two gas giants of Jupiter and Saturn, and then you've got Mars here moving along it, it really gives you that sense of movement in our own solar system, in our own neighborhood. But otherwise, these three planets should be wonderful beacons for you in the pre-dawn skies well into the April month. But you can verify all that with this wonderful software, Stellarium. And I should also mention, how do you tell the difference between planets and stars? Let's just say you don't always have a wonderful pairing or grouping of three all in one shot for you. Well, think of the song Twinkle, Twinkle, Little Star. Stars twinkle, planets don't. That's why it's called Twinkle, Twinkle, Little Star. Let's just look at this star up here, Altair, just above the three planets in the sky. Altair, if you look long enough, it looks like it's shimmering or twinkling at you. That's because starlight is coming from so far away that when the light comes through the atmosphere, the air here on Earth, it gets bent or distorted. We say it's refracting. That's the fancy word for it. And you can see this at home. Get a glass, a see-through glass, and fill it with water. Then take a straw or a silverware handle and put it through that glass. Look at it from the side and write down your observations. See what happens when you put the straw or that silverware handle through the glass. First, predict what might happen, because this is a part of the scientific method. You think about what you want to do, write down what you think might happen, and then write down what did happen when you perform this test, this experiment. So when you put that thing, whatever you pick, the straw or the silverware handle, into the glass, did it shift? Did it move? And if so, it should, you'll see what we're talking about. The light coming through that water is being bent and distorted. The same with the light coming through the air here on Earth gets refracted. But planets, it does happen for the planets, but because they're a lot closer to us, we don't notice it nearly as much. So planets here, they look like steady, bright, unblinking dots. So again, stars twinkle and planets do not. Well, there you have a wonderful kind of roundup of the planets. I hope you're impressed at what you can see just with the naked eye. If you have any of these tools at home, they help you out, of course, as well, a little bit better, but not necessary. We can all enjoy the sky in our own way, but get out now and enjoy these planets that are there to greet you in the early evening and the early pre-dawn skies. I hope you enjoyed this video. I hope to see you again soon as we explore more with Stellarium and the beauty of the night sky. Until then, everybody, keep looking up.